So this study is the ML Bio study, supplementing patients with Ribitol. And this sounds really low tech, compared to a gene therapy trial. But it's actually quite interesting as well, because it's also attacking the root cause of the disease. So here we did put some disclaimers. I should have put some in the other ones as well. So about myself, I can say I'm an investigator in this trial as well, and I've also consulted for ML Bio and also a number of other companies apparently. Okay, so this is, we already talked about this. So this figure, how did you get this to work? Do I have to I have to redo it? No. It's this one here. Thanks. I'm not good at it, I'm sorry. And how do you do it? Oh, here, it's up here, sorry. So this figure shows you, so imagine this is the cell surface of the muscle, and there's this protein called alpha-dystroglycan, which is sitting there on the cell surface. And that's where all the antennas are with all the sugar molecules, what we call glycosylation. They are important, these sugars. So one thing is that cells recognize each other this way. And as Volker talked about, maybe, this confers some protection to the patient if they have just one allele, because then the sugar is a little bit different, and then maybe some bacteria can recognize it. But if you have limb girdle R9, then your function here is not sufficient. And you cannot put these nice sugars that are shown here that not only are signaling, but they also anchor the muscle cells to the extracellular space outside the muscle. So it makes it vulnerable when it's not attached, and that's probably what's producing the muscular dystrophy. And so when you have FKRP, you have a mutant FKRP. That enzyme still works to some extent. And that's the whole basis of trying Ribitol, because if it didn't work, you couldn't push anything through the enzyme. And if you didn't have any FKRP, you were dead. We cannot live without FKRP. So every patient who's ill from deficient FKRP has some FKRP still. And the general idea here is like, it's like a watermill. If you put a lot of water behind the watermill, you can push more water through the mill. And this is the principle here, that you put a big load of Ribitol. Ribitol is normally occurring in your body. It's just overdosing with this substrate, and then you can push more glycosylation through the mutant FKRP, and then at least partially restore the structure here in the molecule. So the nice thing about this is that it is not with all the side effects you get from many other treatments. It's a naturally occurring small molecule. And you also avoid the overexpression of FKRP, which you can get with some gene therapies, which can give cardiac toxicity in some cases. And the company says that it's also convenient that you have to take it orally. I don't know about that. It would be nice you didn't have to take anything like in gene therapy. You just do it once. But of course, it's easy to take, right? It's like a supplement, so it is quite easy to take this medicine. And the way you take it is these granules that you dissolve in water. So it's a small drink twice a day, so quite easy. And it has been tested, and it appears safe. I would also be very surprised if you would have very serious side effects from a molecule you already have in your body, just getting more of it. And it has also been tested in a number of patients with limb girdle R9, and it looks as if it is safe there as well. And also there are some trends in the efficacy which are positive. So this is the developmental plan for Ribitol. The phase 1 was carried out in healthy persons, and this in 14 patients with limb girdle R9. It was tested in a phase 1, and there were trends. So like the CK values dropped when they were giving this, and there were also some of the clinical markers that trended to go in a positive direction. So it looked positive. So now we are doing a phase 3 study. It has started just a little while ago. It started in the US and it has now come to Europe. And there are a couple of sites. I don't know how many sites that are up and going, but I think there are 2 or 3 sites that are open, and there will be a few more to come, which will include quite a lot of patients. You can see there are 80 to 100 patients. So, and the patients we include here are age 12 to 60 if you live in the US, UK, or Australia. But if you live here in Europe, it's from 18 to 60, because EMA did not approve of including children in this trial. I really think it's a little bit strange, because I don't really see a high risk with this drug. Right, and the next slide shows you the flow chart here, and so participants are randomized either to the active treatment or to placebo, 2 to 1. So 2 out of 3 gets the active medicine and 1 out of 3 gets placebo. And it's a very long trial, lasting for 36 months in the blinded period. So which is longer than most other trials in the field. And obviously part of this is because the condition is slowly progressive. After that, there will be, if it works, if the drug works, there will be an open label extension where you can continue to take the drug properly up until it will be registered if it is efficacious. I can't really show you any results because it's just started. I think we are about halfway. Around 50 patients have been included worldwide, mostly in the US and a few sites in Europe, as it is right now. So the recruitment rate looks great, but it will be a very long-lasting study. Yes, and then I will hand over to Nick, who will continue.